Hello and welcome to another video. In this one we're going to be talking about binary searching, particularly in Python, and this is it comes up a lot in interview questions, and I'm not actually going to be teaching you how to binary search today. I'm going to show you how to do it the extremely easy way, assuming you're working in Python. Other languages have similar things to this, but Python has a built-in module that helps you do binary search, so let me show you how that works. If you don't know what binary search is, the idea is if you have a sorted collection, it allows you to quickly find the point in that collection for a value you're searching for. You can kind of think of it as looking for a phone number or a looking for a person in a phone book, because the phone book is in sorted order. So as a human, what you do is you open the phone book to a page, and say you're looking for, I don't know, John Smith, and you open up to the letter L, you'd say, oh, well, I have to go towards the second half of the phone book. So you would kind of think about cutting the rest of the phone book in half and then saying, oh, am I at the S's yet? No, I'm still at, P, but then you would move further onto the alphabet. But yeah, that's kind of like a real world bisection or a binary search, which is what we're going to do. But in Python, there's a helpful module for this, and the module is called the bisect module, and I'm going to show you some basic usage of this function here and how you might use it to do insertion. So let's open up Python, and we're going to make a list, and we're going to make it sorted just to start, just to kind of give you an example. So this bisection really only works if you have a pre-sorted thing. And so you could use this to maintain a sorted list as you insert or remove values. Now, granted, inserting a value into a sorted list is still an ON operation, so often you'll want to reach for a tree or some other data structure instead. But this can be useful for doing fast querying if you've already sorted. So let's take this list here. Let's say that we want to insert the value 11. Now, as a human, I can look at this and be like, oh, okay, well, it should go after 10 and before 20. But, that's because my brain manually did a bisection to find the exact point in here where it should insert. Or it did a linear scan and went one by one and eventually found the value. That's probably more likely how my brain worked. But anyway, let's say that we wanted to figure out the index where we would insert this. And so we can import the bisect module. And the bisect module has a bisect function. And let's see, does it take array first or value first? I always have to look up. It takes array first. So we're going to insert the value into x, and this is going to tell us the index at which we can insert it. So if we did x.insert bisect x value, comma value, this will grab our index and we'll insert that value at that index. And you'll see that x remains sorted after doing this. Now, there is a shortcut to this. The bisect module has an insort function, which essentially does what we just did there. But again, like note, where's the note? Oh, keep in mind that the log n search is dominated by the slow on insertion step. So the insertion of the value has to move all the other values over, so it's generally going to be on. But if you're only doing searches and not inserts, then bisect can be really, really fast. Fortunately, it's a little bit, unfortunately, it's a little bit tricky to find actual values when you're searching in a list using bisect manually. And so Python has helpfully given a bunch of examples for how you might implement indexing into a binary or into a sorted list using bisection or binary search. And so they provide all of these like index, find less than or equal to, which finds values that are either exact or close to the value that you're looking for. But yeah, hopefully this is helpful. I know that every time I've tried to write binary search, there's like 3 places you can have an off by 1 error, and so I always have some difficulty with it, and it's really hard to get right on the first time. But why waste time trying to get it right when you could just use a function that someone else has implemented that works way better? Now, granted, not all interviewers are going to let you use the bisect module, so it's still important to kind of understand how you might approach writing one on your own. Actually, I wonder if we can just read the source code of this, if it's in pure Python or not. Bisect. Yeah, okay. So you can just read the source code here. So it's, you know, essentially splitting in half and doing a branch-wise check. A little bit weird that they didn't indent this nicely, but that's, I guess, the way things go. Oh, I see. There is a C version of this that overwrites the pure Python ones, but you can look at the pure Python one if you want to figure out how it works. But anyway, that's the bisect module. Pretty useful for interviews. I've used this a bunch of times, but almost entirely just in interviews. I don't think I've used this at all in real life. Oh, repos grep, import bisect. I should limit that to Python files. I've used it for Advent of Code. Oh, I did use it in, interesting. I guess I use it in my text editor, but that's literally the only place I've used it other than, you know, code challenges. But anyway, hopefully this was useful. If you have additional things you want me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.